Forget dinosaurs. Step back just 10,000 years, a blink in geological time, and prepare to have your mind blown. The world wasn't just filled with familiar creatures. Giants roamed, bizarre beasts thrived, and the line between myth and reality blurred. Get ready to witness 5 ancient animals so incredible, you won't believe they walked, or flew, this very earth. Imagine Megatherium, a true giant of Ice Age South America. With an impressive body length of up to 6 meters and an estimated weight of 4 tons, comparable to that of a modern elephant, it dominated the ancient landscape. Megatherium's skeleton was a solid structure, with a large pelvic girdle underpinning a massive body. The muscular, thick tail not only served as a balance, but also served as an important fulcrum, allowing the animal to stand upright on its hind legs. This posture made it easy to reach high branches of trees, where young leaves and soft twigs became its main meal. Megatherium's forelimbs were a testament to its potential power. They were not merely limbs for locomotion, but were equipped with long, curved, sharp claws. Unlike its modern tree sloth relatives, Megatherium did not use its claws for climbing. Instead, they were versatile tools, capable of digging out solid underground shelters, peeling back rough bark to expose the soft wood inside, or even becoming a formidable self-defense weapon against dangerous predators. The size of Megatherium's head seems modest compared to its massive body. Its teeth were equipped with large, flat, jagged molars, a perfect design for crushing tough plants. The absence of incisors and canines further strengthens the hypothesis of its mainly plant-based diet. Finally, although there is no direct fossil evidence, given the harsh living environment of the Ice Age, many scientists believe that Megatherium probably possessed a thick coat of fur, a natural coat that helped it resist the cold and maintain a stable body temperature during the Ice Age. They roamed large swaths of South America for a significant geological period, spanning from the late Pliocene, about 5.3 million years ago, to the early Holocene, about 11,000 years ago. Their heyday coincided with the Pleistocene, or Ice Age. Over the millions of years of their existence, Megatherium adapted to live in a wide range of environments, from dense forests to open grasslands, and their fossil remains have been unearthed in countries such as Argentina, Bolivia, Brazil, Chile, Paraguay, Peru, and Uruguay, attesting to their widespread distribution. Their diet was primarily plant-based, with their large, flat, and jagged molars suggesting an ability to efficiently crush leaves, twigs, and perhaps roots and tubers. However, some studies have suggested that Megatherium may not have been a purely herbivore. With their massive size and powerful claws, they were able to chase other predators away to compete for carcasses, or even actively hunt small prey when the opportunity arose, suggesting a more flexible diet than initially thought. Although they moved mainly on all fours on land, the ability to stand upright on their hind legs was a major advantage, allowing them to reach high food sources that other animals would have difficulty reaching. In addition, the strong claws were probably also used to dig deep underground burrows, both as a safe shelter and as a means of searching for food underground. The secret of the existence of Megatherium, the giant ground sloth of the past, has been revealed through the pages of inanimate stone history, fossils found scattered across South America. These precious relics are not simply rotten bones and teeth, but also include footprints imprinted in ancient mud or cave structures that Megatherium itself may have created. The journey to discover this strange animal is a complex story, interwoven between the harsh laws of nature and the perseverance of humans. The natural fossilization process, a miracle of time, has silently preserved the remains of Megatherium. After they died, their massive bodies were gradually buried under layers of sediment. Over millions of years, the organic matter in the bones and teeth gradually gave way to minerals, turning them into eternal stone copies, preserving the shape and structure of a creature that had disappeared. However, these stone books would have remained dormant underground forever if not for the influence of natural forces and human curiosity. Erosion, caused by strong water flows and corrosive winds, along with geological activities such as the uplift of mountain ranges or the subsidence of the Earth's surface, has inadvertently turned over the pages of ancient history, pushing sedimentary layers containing fossils to or near the surface. During the icy Pleistocene, about 2.5 million to 10,000 years ago, the most fearsome predators on the American continent were none other than the saber-toothed tigers of the genus Smilodon. They were not simply big cats, but also hunting machines equipped with deadly weapons. Their sizes varied greatly, from the agile Smilodon gracilis, which weighed as much as an adult leopard, 55 to 100 kilograms, to the powerful Smilodon fatalis, which had a physique similar to an African lion, 160 to 280 kilograms, with muscular forelimbs and a body much more muscular than modern cats. In particular, the new Smilodon populator was a true giant with a weight of up to 400 kilograms and a shoulder height of 1.2 meters, surpassing even today's Siberian tiger. The unmistakable feature of Smilodon is its elongated, flat, dagger-like upper canines with sharp serrations. In Smilodon fatalis, these canines could reach nearly 18 centimeters in length, making them an incredible weapon. Interestingly, they lacked lower canines, making the upper canines even more prominent when the mouth was closed. To be able to use these daggers effectively, Smilodon's skull evolved differently from that of modern cats, allowing them to open their lower jaws to nearly 130 degrees, nearly twice the normal opening, creating enough space for the canines to sink deep into their prey. However, in return, the bite force of the lower jaw was probably not as strong as that of modern cats. Smilodon's incisors were conical and arranged in a curved row, unlike the flat incisors of today's cats, and like other cats, they also lacked molars for chewing. The structure of Smilodon's limbs and feet also shed light on its hunting habits. Its highly developed forelimbs suggest that it may have been an ambush predator, relying on the strength of its forelimbs to knock down and pin its prey before delivering the fatal blow with its formidable fangs. Smilodon was a formidable hunter during the harsh Pleistocene, with a diet focused on large mammals. Muscular bison, ancient camels, deer, elk, giant tapirs, and even baby mammoths and slow-moving giant ground sloths could have fallen prey to it. Isotope analysis of fossil bones has revealed that Smilodon may have had preferences for certain prey species, depending on the abundance and diversity of prey in its habitat. Armed with its powerful saber fangs, Smilodon's hunting techniques may have been different from those of modern cats. Instead of using their fangs to bite and hold their prey, they may have used the extraordinary strength of their forelimbs to fling down and pin down large prey. Then, with a quick and precise bite, the dagger-like fangs would inflict fatal wounds to vital areas such as the neck or abdomen, quickly causing the prey to bleed out and collapse. Smilodon's preferred habitat appears to have been open plains or dense scrub forests and forest edges, where they could easily hide and carry out surprise ambushes. As for their social life, there is still much debate. Although most evidence suggests a solitary lifestyle, the discovery of a large number of Smilodon fatalis fossils at the Rancho La Brea tar pit has raised the hypothesis that they may have lived in groups. Perhaps many Smilodon individuals hunted together when their prey was too large and unfortunately became trapped in the tar pit. However, this is still a mystery without a final answer. Estimates of the lifespan of Smilodon in the wild range from 20 to 40 years, a period of time long enough for them to become true rulers of the Ice Age. Traces of the existence of Smilodon, the famous saber-toothed tiger, are deeply engraved in the soil across the Americas, from the icy regions of Canada and the United States in the north, stretching across the warm Central America to the vast prairies of Brazil, Peru, and Argentina in the south. This wide geographical distribution is a testament to their incredible ability to adapt to a variety of habitats across the continent. The secret of this dagger of the Ice Age has been revealed by scientists through the discovery of countless fossils, precious relics left after tens of thousands of years. These fossils come in a variety of forms, including fossilized skeletons and teeth, where the distinctive long, flat canines are an unmistakable signature. Skull and jaw samples provide insights into the unique head structure and special biting mechanism. Limb bones and vertebrae reveal the powerful body size, muscular build, and locomotion of this fearsome predator. Although rarer, fossilized footprints also help paint a picture of how it moved across ancient landscapes. Imagine the woolly mammoth, a majestic icon of the Ice Age. Massive in size, comparable to or even slightly smaller than their African elephant cousins today, adult males could grow up to 3.4 meters tall and weigh up to 6 tons. They wore a dense coat, with a soft undercoat that kept them absolutely warm and a long, coarse outer coat that acted as a solid shield against harsh snow and wind. Their fur was often dark brown or jet black, blending in with the icy landscape. The highlight that cannot be missed is the pair of curved tusks, which could be up to 4 meters long in adult males. Not only a powerful weapon in combat or a tool for digging through the snow to find food, but also a symbol of strength and authority. To adapt to the cold, their ears were significantly smaller than those of modern elephants, helping to minimize heat loss. The flexible trunk retained its familiar functions: feeding, drinking, communicating, and grasping. Another unique feature was the large fatty hump on the shoulder, which served as a valuable energy reserve, helping them get through the harsh winters when food was scarce. The woolly mammoth's jaw was also specially designed, with 4 large molars, each with multiple hard enamel ridges, constantly being replaced to grind down the tough plants of the tundra. The short tail, covered with thick fur, also served as an effective way to keep warm. Finally, the large, well-padded feet helped them move easily and steadily over slippery surfaces of snow and ice. This amazing creature has been around for a long time, appearing in the late Pleistocene, around 400,000 years ago, and many populations persisted until the early Holocene, around 4,000 years ago, with some small groups holding out even longer in isolated areas like Wrangel Island, a testament to their remarkable adaptation to the harsh environment of the last ice age. In the frozen world of the Ice Age, the woolly mammoth developed a lifestyle perfectly suited to its harsh environment. Their diet relied heavily on the vegetation available in the tundra and frozen grasslands, including low grasses, shrubs, mosses, and other plants. Their massive curved tusks were not only weapons or symbols of strength, but also useful tools for digging through the dense snow and ice, searching for buried vegetation. Like their modern elephant relatives, woolly mammoths probably made seasonal migrations, moving in response to changes in food and water availability to ensure the survival of their herds. Fossil evidence and comparisons with the social structure of modern elephants suggest that woolly mammoths likely lived in herds, with complex social systems in which family groups were led by adult females. Their ability to survive in cold environments was the result of a host of remarkable adaptations: thick fur that kept them extremely warm, small ears that minimized heat loss, short hair-covered tails, and fatty humps on their shoulders that served as a large energy reserve. Their reproductive cycle was probably similar to that of modern elephants, with long gestation periods and single births, ensuring careful care for the next generation in a challenging environment. With these characteristics, the woolly mammoth conquered vast cold lands across the northern hemisphere, from Alaska and Canada in North America, stretching across Europe to Siberia in Asia, living in harsh tundra, vast frozen grasslands, and even cold northern coniferous forests. The mystery of the woolly mammoth has gradually been revealed thanks to the rich evidence collected by scientists. The mummies of woolly mammoths were preserved almost intact in the permafrost of Siberia and Alaska. These icy gems not only retained their external appearance with thick skin and fur, but also preserved their muscles and internal organs, providing the most realistic view of the biology of this animal, with famous individuals such as the Berezovka, Lyuba, and Yucca mammoths. Interestingly, images of woolly mammoths have also been depicted in cave paintings by prehistoric people in Europe, proving the interaction between humans and this giant animal in the past. In addition, artifacts such as tools and jewelry made from mammoth ivory have also been found in archaeological sites, showing the close relationship between humans and this elephant. During the harsh Ice Age, a large creature with thick fur crossed the frozen lands, the woolly rhinoceros. With an impressive size, a body length of up to 4 meters and a shoulder height of 2 meters, weighing nearly 3 tons, they were not inferior to modern rhinos in terms of stature. Their most prominent feature was their natural coat, a thick, dense coat with a soft undercoat inside to keep them absolutely warm, and a long, coarse outer coat to protect them from the wind and snow. The grayish-brown or yellowish-brown fur color helped them blend into the icy landscape. On their muscular noses were a pair of characteristic horns. The front horn was much larger, up to a meter long, flattened on both sides and curved forward, while the back horn was smaller and more rounded. This horn, made of keratin similar to human fingernails, was believed to be a versatile tool for kicking snow to find plants, participating in battles for territory or mates. The woolly rhinoceros's low, stocky body, with short but powerful legs, was well adapted to moving across icy and slippery snow-covered terrain. Like the woolly mammoth, it had small ears to minimize heat loss, and a short tail covered in dense hair to keep its hindquarters warm. Its broad, flexible upper lip was a great advantage in grazing on low-lying grasses and plants. Its teeth were also equipped with molars with hard enamel ridges, capable of crushing the tough grasses of the tundra. This resilient rhinoceros appeared in the late Pleistocene, around 350,000 years ago, and accompanied the woolly mammoth and many other megafauna throughout the Ice Age. The woolly rhinoceros developed a specialized diet to survive in the harsh environment of the Ice Age. They were strictly herbivores, feeding on the grasses, low shrubs, mosses, and other plants that dot the cold tundra and arid steppes. Their large, powerful front horns probably played an important role in pushing away thick layers of snow and ice, allowing them to reach buried vegetation. Their habitat ranged across the northern hemisphere, from permafrost to barren steppes, suggesting remarkable adaptations to low temperatures. Although they may have made seasonal movements in search of food, they probably did not migrate over long distances like mammoths. Little is known about their social life. However, based on the habits of modern rhinos, it is likely that the woolly rhino lived alone or in small groups, usually mothers and calves. Their reproductive cycle was probably similar to that of modern rhinos, with long gestation periods and single births, ensuring careful care for the next generation in a challenging environment. Their widespread fossil distribution, from Spain to Siberia in Europe, across northern Asia, and even to Alaska and Canada in North America, is a clear testament to the success of the woolly rhinoceros in conquering the cold lands of the Ice Age. The mystery of the existence of the woolly rhinoceros has been revealed through a variety of fascinating discoveries. Scientists know about this animal mainly through the numerous fossils found, including bones, teeth, and especially the characteristic fossil horns with a flat shape and curved forward, an unmistakable sign. Like its companion the woolly mammoth, some woolly rhinos have been fortunate enough to be preserved almost intact in the Siberian permafrost, becoming invaluable time capsules that provide vivid details of their skin, hair, and internal anatomy. A notable example is the Coelodonta antiquitatis woolly rhinoceros unearthed in Siberia. Even more interestingly, the woolly rhinoceros has been depicted vividly in cave paintings by prehistoric people in Europe, showing the interaction between humans and these giant animals, with clear lines depicting their two horns and dense fur. In addition, archaeologists have also found artifacts such as tools and jewelry crafted from woolly rhinoceros horns, revealing more about the relationship between them and ancient humans. During the Pliocene and Pleistocene epochs, the Americas witnessed the existence of an extremely unique creature, Glyptodon, an extinct mammal of the suborder Glyptodontia, distantly related to modern armadillos. Their most prominent feature was the massive bony shell that covered their entire body, a natural armor likened to a turtle shell but made up of thousands of small bony plates, osteoderms, that were firmly fused together. This dome-shaped shell was not only an effective defense against fierce predators, but also varied in size and shape depending on the species, ranging from 1.5 to 3 meters long and weighing up to 1 to 2 tons. Some Glyptodon species even possessed sharp spikes or strange shapes on their shells, adding to their strange appearance and self-defense capabilities. Their overall size was about that of a small car or a hippopotamus, indicating the massiveness of the animal. The Glyptodon's head was relatively small and rounded in relation to its body, with a robust skull. They had powerful jaws with cylindrical, jagged molars, well suited to crushing tough plants. Notably, they lacked incisors or fangs. Glyptodon's limbs were short, robust, and equipped with strong claws, suggesting that they were not agile animals but rather slow-moving. The Glyptodon's tail was also an interesting feature, with great variation between species. Some species had short, rounded tails, while others had long tails with bony rings or spikes at the end, which could have been used as a powerful defensive weapon. This strange creature first appeared in the late Pliocene, about 5.3 million years ago, in South America, and survived until the end of the Pleistocene, about 11,000 years ago. Some species even migrated to North America during the Great American Exchange and continued to exist there until their extinction. With its distinctive tooth structure, Glyptodon is identified as a herbivore, with a diet that probably included grasses, leaves, and other plants growing on the ground. Its powerful teeth allowed it to effectively crush even tough plants. It adapted to a wide range of habitats, from open grasslands to dense scrub forests and open woodlands in both North and South America. However, with its heavy bony shell and short limbs, Glyptodon was not an agile animal. They probably moved slowly, spending most of their time foraging and conserving energy. Their thick bony shell acted as a mobile fortress, providing effective protection against formidable predators such as the Smilodon saber-toothed tiger or the giant short-faced bear Arctodus. Some Glyptodon species even evolved tails with sharp spikes or bony rings, forming a more powerful self-defense weapon. Regarding their social life, the information we have is still limited. Based on the habits of their modern armadillo relatives, it is likely that Glyptodon lived alone or in small groups. Their fossil remains have been found widely in South America, including Argentina, Uruguay, Brazil, and Bolivia, and some species have also expanded their range into North America, especially in the southern states of the United States and Mexico, indicating the adaptation and wide distribution of this strange animal. The secrets of the Glyptodon, a strange creature with a massive bony shell, have been revealed thanks to characteristic fossil discoveries, the most prominent of which is the hard, bony shell carapace. This natural armor is not only large in size but also has excellent fossilization ability, becoming an easily recognizable mark in the ancient ground. The natural fossilization process has favored the preservation of the hard parts of the Glyptodon, helping them to go through millions of years without completely decomposing, creating conditions for mineralization and the formation of priceless stone relics. Over time, erosion processes caused by water and wind, along with geological activities such as tectonic uplift and subsidence, have gradually presented these fossils to the surface of the Earth, opening up opportunities for human exploration. Paleontologists have played a key role in the search for and study of these remains, conducting systematic excavations in areas that are likely to contain traces of Ice Age animals in the Americas. In addition to professional scientific efforts, many Glyptodon fossils have been discovered accidentally by local people, farmers in the process of cultivating, or those who work related to the land. These large and strange bone fragments aroused curiosity and prompted them to inform scientists. It is thanks to the combination of natural factors and human efforts that we have clear evidence of the existence of Glyptodon, allowing us to reconstruct images, estimate size, speculate about living habits, and better understand the evolutionary relationships of this unique mammal. You want to learn something new every day? This channel is for you. Subscribe to get the latest tutorials and lessons.